Yeah, hi, good evening, everyone. So today, actually, week 10 is released, but this time week 10 is refresher week. So we will discuss the week 9 topic. Okay. So week 9, so deadline is also today. So week 9 is basically dynamic programming, and week 9 is important for the OPP exam. So you can assume at least one problem based on the dynamic programming also in the OPP exam. Okay, so in week 9, actually, Professor have discussed some problems that can be solved using this dynamic programming approach. Okay, so that we will discuss, and simple problems we also given in the assignments, and we will also discuss in the live coding session this week. So you will get some idea how you can approach the dynamic programming problem. Okay, so before starting the session, if anyone have any query regarding anything. So this time we found that quiz 2 score is better than the previous term. Okay. So any feedback for the quiz 2? How was the paper difficulty level?
Sir, there was this question of MST.
MST question.
Yes, sir.
Okay. What?
I have something like I have doubt in some option.
Mm-hmm.
So I think like those option which are marked correct should be marked wrong, because I find different MST graphs for
Okay.
some situation.
Okay. So do you have that question right now?
Yes, sir. Yes, sir. I'm looking for it.
So please share that one. Okay. Any other? Any other query? So I think you have received one announcements for the OPP exam. So this time OPP date is only 7th April. Okay, but that is there are two slots on the 7th April.
Is there any possibility for the extension of 1 day for this submission for week 9?
Actually, I tried, but this is not possible right now. So actually, they are just finishing all the eligibility criteria for the end term exam. So they need to send all the details to the TCS centers. So actually, I tried today, but they said it is not possible. So just complete it by today.
Okay.
Okay.
Sir, will there be any OPP preparation sessions like that?
Yes. So from next week onwards, so the TA will take revision sessions or preparation session for the OPP, and we will also release one mock, not mock, basically some practice questions. You will get some idea from that questions because that questions are belongs to the previous OPP. So total 8 question approx we will release, and we will also conduct one session to solve that mock problems. Okay, so next week one session will be based for the week 11 and another session for the revision type OPP. Okay, and TA will take all that revision of the OPP.
Sir, should I
Can we
share?
have a session every day, like for OPP? Is it
Every
possible?
day. Okay, so I have to check with the TA. So actually Monday is taking, Tuesday he's taking, Wednesday we are taking. So I think session is going on every day. So I'll also check with the TA if he's able, he can conduct more session. Okay. Or only for the OPP's preparation. Okay, so that we will update in the calendar if any changes happen. Okay.
Yeah, hello sir.
Sir,
Good
Yes, sir.
evening.
should I share the question?
He Divyans. Okay. Divyans or Sasi who talk?
Yes, sir.
Yeah, Divyans. Go ahead. Share this question.
Yeah.
Yeah, hello sir.
Yes, Sasi.
Sir, actually today mail regarding OPP PDS OPP exam. They
Mm-hmm.
mentioned only 7th April.
Yeah, so this is changed actually happened this time. So your OPP exam is only conduct on only 7th April, but two slots are there actually. Two timings are there. So they will schedule accordingly in 2 times. And 7th is Sunday actually, so I think you can appear in any one.
Yeah, sir. But 13th is
13th is Saturday. Actually, this time students are more in the Python course, so I think they are planning to conduct OPP for Python alone on 13th. So we changed a little bit.
okay, sir.
Sir, we have DBMS also. So DBMS and PDSA both will be on 7th.
Okay, so did you check on the mail what dates are actually? So DBMS is also scheduled on 17th or both 17 and 13?
1 minute, I'll just
Only
check.
7th, sir. Only
It is
Only
only
7th, I think.
morning also, morning DBMS and the 2 slots. You can choose morning DBMS slot is available, PDSA slot is available. Same way afternoon also DBMS and PDSA slots are available.
Okay.
But it is on 7th only.
Yeah.
We have both these.
Yeah,
it is quite challenging, sir.
so maybe some resource issue actually they are doing in this manner. So this is totally operational things. So how
But
they are actually planning to manage.
PDSA should be clear OPP for the
No passing criteria for the PDSA.
okay, only for DBMS, right?
Yeah, only for DBMS.
Okay.
DBMS, one slot is from 10:30 a.m. to 12, and PDSA also is the same slot. And afternoon DBMS is 2 to 3:30, and PDSA is 4:30 to 6:30.
Okay, so I think they will manage the schedule based on this. If someone are doing the both courses, so they will fixed different slots. If they are some students are not doing both, then they will schedule at the morning slot which are classing. Actually,
But
so
have the timings already been allocated?
They
I think
said
not.
that the mail will be sent today.
So
Confirmation mail, email will be sent to you today. That is
yes,
what it is.
still you have this week and next week, so I think they will send the final mail to you.
My request will be at least for OPP hour, if not more than an hour. At least every day 1 hour session, late evening, like 7:30, 8:30, something like that. It'll be better so that more
Okay.
students will be
Yeah,
available.
I have already
Not the
posted.
afternoon session, so that we will not be able to attend.
Yeah, I have already posted some important area where you need to focus for the OPP exam. So I have already discussed that with TA. So that I'll check with the TA. So if he is available to take every day, so I think he can. But I'll update the calendar accordingly after confirmation. Okay. Okay. So this question, yeah, Divyans.
Yes, sir.
So what's your doubt, which is not correct?
Sir, I am saying like if this graph is given, then if we put all the weights distinct, then there will be many more possibilities for MST, right? And if we consider those possibilities, then there will not be only one MST for this graph.
No, why? If all weights are distinct, then how you are getting more than one MST?
Yes, sir. I'll show you. Like if we draw some figures, so this can be a possibility, sir.
Okay.
This, like this. This can be one possibility.
No, just mention the weights also. If just take some example with the unique.
Okay, sir. Like.
So this is very clear. If all weights are distinct, 1 second, Divyans. So if this is very clear, if all weights are distinct, definitely first 3 smallest weights will selected for the MST. So how you can change the age then?
Yes, sir. Sir, I am saying like if we take these 3 as first three smallest, like 1,
Uh,
2, and 3. Then this is also an MST, right?
but why you are changing the weight?
Cause it is not given here like
No,
which
this is given. No, this is given
which weight
W1,
to be
W2.
taken as least and which weight to be taken as like maximum, right?
No,
So,
actually here this W1, W2 are actually weights, but the value is not given. Okay.
hmm, hmm, hmm,
So if you are assuming any value for this,
hmm,
any fixed value for this, okay, you cannot change the value for to the answer to change your answer. If you are assuming any value for this graph, W1 equal to something and W2 equal to something like this,
hmm, hmm.
so then you can only create only one MST from that.
But sir, it is not given, so like language is very ambiguous, right?
No,
Uh,
why it is not given? So it is mentioned that in the graph, if all given weights are distinct, okay. So
hmm,
here we are talking about the graph which is given with the W1, W2 like this, and
hmm,
it is in first option it is mentioned that if all given weights are distinct, then only
hmm,
one unique MST is possible. So
hmm,
here it is mentioned that for this graph, if weights are distinct,
hmm.
then for that graph only unique MST is possible.
Sir, I am not saying like I'll take same weights or anything. I am saying like uh, if we arrange like if what if this W2 is 1, what
Hmm.
if W3 is 1, like I am giving you the possibilities. This can be also possible, right? If we are considering the distinct weights,
But this is general
then there
thing.
will be many more possibilities for this particular graph. And also for sir option 4, it is given like if W1 and W4, let me paste it here. Hmm. So, sir, for option 4, it is given W1 and W4 are the same
Because
and smallest.
one thing, first
Hmm.
thing is that you are assuming different weights for the input graph. Okay,
Yes, sir. Yes, sir.
so that is not correct for the this type of problems. So here we are assuming that these are the weights. Okay, and these
Mm-hmm.
are distinct weights. So actually, this contains some specific value.
Hmm.
Okay, and
Hmm.
for that value, actually, we are looking for the MST. We are not changing the input graph for the answer.
That is, I
So,
understand, sir.
uh,
Why I am telling that if we change the weights, right? It is
so
not
that
given what will be the value of the weights.
no,
I am saying like,
this is just a representation of the weight. So the value are not given, but this is representing some weight.
hmm,
Okay, for the conceptual testing, this is
hmm,
representing some weights, and these are distinct.
hmm.
And then only one MST is possible for the fixed weights.
But sir, the same question arises like this is also possible.
So you are
This
changing the
is
value
also
of the
possible.
weights. So you are
This is
changing the
also,
value of the weights actually. Suppose
hmm,
if I replace the W1 by the 10, okay,
hmm, hmm.
then so for the another answer you are changing W1 equal to with some another value. So that is not possible. Input is fixed.
I I am not changing the value,
Okay,
sir.
okay. So
I am
okay,
telling like this can be a possibility, right? Since it is not given.
how this can be possible? Just assume any fixed weight. Just replace all the weights in the input gram. Then can we make different MST
Wait, sir. So
without
for
changing the value? It is not possible.
particular values, I am saying like for certain values, this can be a possibility. Okay, this can be only one possibility.
Hmm.
But I am saying since it is not given which weight is smallest, which weight is largest. Okay, so this can also be a possibility, and this can also be a possibility.
So again, I am saying that here W1, W2 are representing some weights and that are fixed.
Hmm.
Why you are changing the values every time for this? So this is W1, W2 is just a value, and we are not to mention that value.
Okay,
But
sir.
input
Like let me.
input input graph definitely will contain only single value, na? So we are not giving multiple inputs graph.
Sir, this is one possibility. Like this is one graph. Okay. For this, there will be a unique graph. I understand. Okay. Now I am saying like, what if W2, W3, and W4 is given as a distinct and smallest. Okay. Like 1, 2, and 3. There will also one MST for this, right? Since it is not specified in the question, like which weight is smallest, which weight is largest, then we can take this possibility as well, this possibility as well. So hence,
So
for
that means you are assuming different inputs graph.
yes, sir.
So, but
Different
then
inputs
there is no
for the
meaning
weight.
of this question.
Different input for the weights, sir. I am
Inputs for the weights. Yeah. Why different inputs for the weight?
sir. We can do it, right? Cause it is not given here.
This is not a variable. This is a weight actually. This is not a variable.
I am satisfying all the conditions. Like these are distinct weights.
If you are assuming this type of condition, then no meaning of the questions.
Okay, sir. Like for option 4, let us
just replace this W1, W2 by some fixed value. After that, apply the conditions.
Okay, in that
input
that
graph
way I understand, sir. But like
input.
What is this way?
Suppose if you are giving one input graph, MST is for MST we calculates for some specific graph, na specific input graph. So we are just discussing the same things. How we can ask this type of questions like we are changing continuously the inputs, edges, weights. Then you cannot get any fixed answer for that. These are representing some weights value. These are not variables, so we are not assuming that these values will be changed.
Sir,
this is fixed.
Like sir, for option 4, like if I go with your words, then for option 4 it is said that W1 and W4 are same and smallest. Okay.
Yes. Okay.
So that means that we have to keep W1 and W4.
Definitely.
Now other weights are distinct. Then only one unique MST is possible.
Definitely.
So other weights means like I have to take only one edge, either W3, either W5 or W2, correct?
Yes.
So if I take W2 as a possibility, then this will
again the same things you are trying to do. You are changing the weights.
Sir, but I'm not changing the weight.
What will say that we have changed? मतलब data
yes, sir, yes, sir. जब दिया नहीं है तो फिर कैसे?
We can say he is changing if it has
any statement we are asking about some input graph, so that only fixed values are possible, for input graph.
And we don't know that.
We don't know that, but condition you need to check.
Yes. So
this W1, W2 are actually some fixed values for the input graph. Do not change the value for the statement.
Agree, sir. W and W4 we don't have issue. The issue is that now the graph will depend on the second minimum. Second minimum weight. Whatever weight will be second minimum, the graph will look like that. That's the issue.
So first thing, in the fourth statement, W1 and W4 are the same and smallest. Okay.
Yes,
so that means these two edges definitely will be selected in the MST.
Yeah, no issue.
Okay.
Yes.
And after that, all remaining three weights are distinct.
Yes.
So that means the smallest one will be selected.
Exactly, and we don't know which one is the smallest one. So there could be three possibilities. W4 could be the smallest one, W2 could be the smallest one, or W3 could be the smallest one.
Aladdin, may I suggest something?
Yeah, Ravi.
This kind of problem, if you go with varying things and saying I cannot determine, the best way to solve is if you are able to find an anomaly, then the statement is not holding good. If you are able to show that this set of weights, this statement is correct, and this set of weights, the statement is wrong, then the statement is wrong, because statement has to hold in every scenario.
Exactly that.
So if you are able to prove it doesn't hold, it is done. You don't have to actually say, because of this, I'm not able to determine. It's as simple as that. Then you will be...
Actually, the thing is that for W and W4, it is saying smallest and minimum. So it is fine. There is no ambiguity in that. But after that, there are three possibilities for this tree. Like if we want to
Correct.
make an
That's
MST
what I'm
out
saying.
of this.
See,
Mhm.
if we can list out the number of cases here between the two of us or within
Yes.
the entire group,
Mhm.
my point that I'm trying to make is,
Mhm.
if you are getting two answers for the
Okay.
same statement,
Yes.
the statement is false
Huh. So
because
that's
it
why
is not holding under every circumstance.
exactly. That's why 4
So
should
you
be
prove
false.
that it does not hold and it is done. So if you say multiple scenarios and all that, take one scenario. If you are able
Mhm.
to actually prove it is not holding, then it is not holding. It's as simple as that. Leave it at that. You don't have to actually get into this case it is yes, that case it is a no. You will have trouble with these kinds of questions if you go by that approach. You will unnecessarily lose time. Just prove, even with one statement, if you're able to prove
Mhm.
it doesn't hold, it doesn't hold. Simple, leave it. Just keep going. That's all.
Okay. 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 So the thing was that like there was ambiguity in the option for that one. Okay.
No, I think not. There's no ambiguity here. Actually, you are changing the input graph. This question is created for some fixed input graph where
Mhm.
the weights are not given, and we are assuming some weights for that input graph.
Yes. Sir. Yes.
But
Sir.
that weight will be fixed. Okay,
Yes. Sir.
input graph will be only. Input graph will be only one possible. Okay. Regarding
Input.
that, we are asking the question. So, what are the
But sir,
options we
it
are
goes
possible?
again on that thing, like we, since we don't know, then there is possibilities, right? For the fourth option,
So,
W2 can
suppose
also be the second minimum,
one second.
W3
If
also,
so
W5 also. Yes, sir.
no, if suppose if you're taking any, or suppose if you are taking one input possible, like W2 is the next third smallest.
Yes.
Okay,
Yes.
then this is the fixed only one input.
Yes.
Just
For that we
Mhm.
check
will
the
get only one.
yeah, just check the condition. Check the condition for only to prove this input.
Okay.
For that input we will get that graph. Yes,
Hmm.
sir.
Huh.
Sir,
But
what is
again,
the
if
guarantee?
you are changing the inputs for the every time, so then you will get a different possible output. But for every one fixed input, you will get only this statement true.
Yes, for every possibility we will have
Huh.
unique MST.
Yeah, unique MST. So this is not mentioned that we are changing these value. These are just a representation of some fixed value.
Okay. Like that time I was confused
So
in
these
that.
are actually some theorem-based questions where
Mhm.
we are just trying to prove some things. So for that, we assume some input graph, fixed input graph.
Hmm.
Okay, so we are not asking that if these values are changing, then how many possible MST are they available like this? So these are the just theorem-based questions. If you know the conceptually MST properly.
Okay. So whatever the data will be, there
Sir,
will
as
be
per
input.
my approach, only this option was correct because it was following everything.
Because you are just assuming the weights are changing, then
Mm-hmm.
all the statements. Because of that, I'm asking. So there's no meaning of that type of questions if you're assuming that in this inputs are changing.
Okay, sir. So,
Sir, may I interrupt?
Yeah, because
Sir, sir, it is nowhere mentioned that we can randomly allocate values to these weights.
this is
It is
also not
given that,
mentioned.
yes, sir, it is given that W1, W2, W3, W4, and W5 are fixed. It
That's
is
where it
These
is
are
assumed
the
that,
creating.
weights.
That is the thing where it is creating possibilities, right?
hmm.
hmm. Yes,
These
sir,
are the weights actually.
Divyansh
These are
bhai,
not the
it
variables.
is nowhere mentioned that we can randomly allocate values to the
Hmm.
ones which are not mentioned. Like, suppose in option 4, W1, W2 is mentioned that it is same and smallest, but for the
Hmm.
other weights, it is not mentioned that we can allocate values randomly. That's what is assumed that the student is knowing already.
But the sense is that if it is not mentioning, then there is an another view now. It is not mentioning that is these have many possibilities, and
If it
possibilities
was
are there.
mentioned, then we can randomly allocate. Otherwise,
No,
we can't.
actually, it
It
is
is like,
mentioned that it is already mentioned that if W1 and W3 are the same and largest amongst all weights,
Hmm.
and other weights were distinct,
Hmm.
then only one unique MST is possible. They are
Yeah.
saying that W1 and W3 are same and largest.
Hmm.
So if you put values
Hmm.
which are same for W1 and W3, You should be able to find the
Only
MST.
one is possible because
Only one
whatever
is
be
possible.
the weight of W2, W5, W4, it doesn't matter,
Exactly.
right?
Whatever will be the weight,
Yes,
Yeah.
you
but
can
it is
go.
saying largest among all weights.
That's why
We
we
are
are
not
taking
discussing
W1,
on the
W2.
That
option
is why
like
it is
thing.
correct. That is
Yeah,
why it is correct.
yeah, that is why it is correct.
Actually,
But
option 4 we had issues.
this condition is not following in option 4, right?
No, in option 4, it is saying it is smallest among all weights.
Yes, so we will take
Mm-hmm.
W1 and
So
W4 anyhow.
you put some values which are
Hmm.
first largest and see if you can get a single MST unique, and
Mm-hmm.
you put smallest values and then see if you can get a unique MST.
Exactly.
Exactly.
Like if we put 3 times 3
If
values, we will get 3 different trees.
you will get 3 different answers.
Hmm.
So all the 3 are correct.
So there should be no distinct MST, na? Like unique MST should not be there. We have possibilities for MSTs. That was the thing I was
Sir,
getting.
Sir, today they have put the answer transcript for quiz 2, but it is giving error while opening.
That is not opening.
It's giving error 404.
Okay, so I think they will update soon if it is run. I'll just check with the ops team regarding this.
File not found. The requested URL was not found on the server. If you entered the URL manually, please check your spelling and try again. It is saved. 404 not found.
Okay, I'll check this with the ops team.
Because they were uploaded the quiz answer paper also today in the afternoon.
So okay, yeah, regarding this question, actually this question is actually the process to solve this is just a just mention some weights which are given in the statement, like W1 and W4 are the same and smallest, just put some value as the smallest, and remaining for remaining weight just put some different distinct value which is greater than the smallest.
Greater than the smallest.
Okay, then check what is the possibility, but do not change these value in between like this. You are just changing the value to the others. Because these are the weights. These are the weights which are we are assume that these are the weights, and it is also mentioned in the first statement, first line before this image. These are weights. These are not variables, so you can change the values for the input graph.
But sir,
Okay.
like W1 and W4 are same, right? Then after that, whatever
so
weight
I
we will
got
put
your
the
point.
minimum,
I got your point. You are just assuming that if suppose W5 is the third smallest.
yes, like if there is
Yes,
a
sir.
W3 is the third
Sir,
smallest.
had it
like
been
that.
mentioned clearly, like
yes, sir.
we can't,
Like,
then it
if
would
there
be
is a fixed data, we
easy.
are not knowing now what is that fixed data. If it
Cause
has
for
the weight has been fixed.
yes, sir. Cause for our assumption, option 3 is getting right, no matter
So,
what we choose as
yeah, I
weights.
assume that this type of question is also asked in the previous term. So, where the graph is not mentioned, but it is given in the statement, like if the weights are distinct in the input graph, okay,
Then
then
it would
yeah.
make
So
sense.
then,
Yes.
then again, you will just claim these things.
No, sir. No, sir. Like
Why?
if the graph is not given, then obviously we will not claim that. But since it is given, then we are claiming.
So graph is not given, but we are assuming that the graph have distinct weights. But still, you can change the weights on the different edge, and then you can assume that this is not possible. Unique MST is not possible. Different MST are possible. So this is the not correct argument for this. Okay, MST we always calculate for the single input graph. We are not trying to calculate the MST for the multiple input graph.
We're not trying to change the graph. That is
We
the
are not.
point.
Yeah, we are not
We are trying
changing the
to
input graph.
find the MSP for only one graph. If we change the values for the weights, then we have another graph. Then we can't
Yes, they
talk
are all
about
3
MSP for
different graphs.
yes,
Actually,
yes.
they are all 3 different graphs.
No,
First
ma'am.
one has distinct weights. Second, I'm not talking about. Third question, it is saying 2 weights are same and largest amongst all the weights. And in the last question, last statement, 2 weights are same but smallest amongst all weights. So there are 3 different graphs, and you have to find the MST.
3 input graph, but
Yes, there are 3 different graphs. They are not same graph.
No, yes, ma'am, you're right. But for one option, we have only one graph. And for one option, we can't have three graphs, right?
Yes, right.
No,
That
no,
is what
here
I'm.
they have stated what will happen if W1 and W3 are same and largest. And in the last question, they're saying W1 and W4 are same and smallest. So
Got it, ma'am. Got it.
what it means is they are talking about three different graphs with different weights. In the first one, all the weights are different and distinct. In the third question, two weights are similar, same and largest. And fourth graph is two weights are same but smallest. So you have three different graphs and they've asked questions regarding that.
No,
Yes, ma'am.
graph is given and that is fixed in the question statement, and the bits are also mentioned this by some representation W1, W2, W3. So this is one fixed graph. Okay.
Yes.
We are not changing that. We are not finding the possibility of the input graph. Okay. We are
They
just
are
looking.
giving different inputs all the
No,
time.
we are
Different
not.
inputs for the different weights.
Yes, but for one instance, we will get only one unique
Exactly, that
Yes,
is
for
the
one
ambiguity
instance,
now.
there is only one graph. For
That
one
is the
instance,
ambiguity
there is
now.
only one graph.
What I considered uniqueness is whatever I am drawing in my paper, that should be same in your paper. That is uniqueness. I was thinking at that time.
Yes.
But this question is not regarding the input possible graph. Here, inputs graph is only one graph. Okay, we are not looking to check how many inputs graph are possible, then you are calculating the answer. So this is not mentioned in the question statement also. We are so how many unique MST are possible for all possible input graph. This type of things are not mentioned.
Yes.
Okay, so for this type of theorem based question, just assume the only one possible input graph and check the concept logically like this here. Okay, and we are not looking for the, so like one question, if you remember that we discussed in the revision session, where some weights are given like 1, 2, 3 and 4. If you remember that 4 nodes are there and all possible weights are given, 6 weights are mentioned that. So what is the maximum possible weights for the any MST? At that type of graph, it is mentioned that what is the maximum possible MST weights. So in that case, you have to find out the all possible input graph. But it is not mentioned in this problem statement or in any statement. Yeah, so this is mentioned.
Only one unique MST is possible. Only one unique MST is possible. Only one.
This is for, yeah, this is for only one fixed input. So that is given in the graph. So this is only single graph. Okay, and we are not looking all possibility of the input graph. Yeah.
Still, sir, it lacks like little information. If had been mentioned, then it would be easier for approaching the question, right?
But actually, I have already checked this submission thing. So we are not getting any like sometimes actually based on the records, we also assume that students are confused in this. Like, okay, but most of the submissions are correct for this question. Okay. So related to the all remaining questions, so same ratio we are getting the correct submission for this question also. So for regarding ambiguity things, this submission rate is also actually become different. If the question is really ambiguous, then the submission ratio, like how many correct, how many not correct, like this is also affected. So this is just assume that at that time what you are actually thinking regarding the question. So this is totally different.
We missed the general assumption that we should made during solving MST, I think.
Yeah.
Okay. Thank you, sir.
Thank you.
Okay, so regarding the beak 9, let me share my screen.
So why is the answer transcript not opening?
So I'll check this with the ops team. So I'll convey this message to the ops team, and they will check what happened actually. So it is not open for everyone, or It is only for
I
some.
don't know about others, but I tried opening it and I did not open. Russian Prabha is also saying the same thing.
Okay, okay.
What about others? Has anyone else tried to open the answer transcript in the downloads?
Yeah, still I checked with upstream. Okay, I'll convey this message too, so they will check it and corrected it. Okay.
Seems like the scores are already come on the dashboard.
Score
Scores have
released.
come?
Oh, score is released.
Scores for everything except DBMS. DBMS is still not showing.
Yeah, it's actually it is under process. All the
Yes,
things are under process.
PDSA the scores are showing, but DBMS they are not showing.
Is there any particular reason why you are going for both DBMS and PDSA OPPs on the same day?
So this is totally resource things. Actually, how the Python this time have lots of students. I think 5,000 approx. So they are just managing the things. Okay, and they are trying to complete all the OPP on the 7th and maybe Python only on the that 13th, like this. Because of that, they are just changing the slots.
Honestly, it's a
Okay,
disadvantage.
because Proctor's that is depends
It's
on the
going to be
Proctor's
difficult.
availability.
True, agreed. There are organizational issues, but it's
Yeah, but you can just write mail to the support regarding this if you are facing any difficulty like this. Okay, just write the mails.
Yes, but they do have Python also on, no, not on 7th. Not a single slot for Python students.
Maybe
on
3
7th.
slots on. Okay, so let's start this DP dynamic programming. So I hope you have watched the video, you have done the assignments because today is the last date. But still, we will discuss the concept, all topics. So regarding the DP things, so dynamic programming is a different approach to write the algorithms for the to solve the problem. So similar to we have already see this greedy approach, divide and conquer approach. These are actually algorithm design techniques. How we are designing the algorithms and how we are solving the problems based on this. So dynamic programming is the approach where we can solve the problems based on two properties. That first is optimal substructure property and overlapping subproblems. So these are the two property. If any questions have these two property, then we can solve that problems using the dynamic programming approach. So basic idea of dynamic programming approach is if we can solve the problems by solving the sub problems. Okay, so if we just divide the main problem into a smaller sub problems and we get the overall optimal solution by solving the sub problem solution. Okay, if you're combining the solution of sub problems, so like that then we can also reuse the solution of the smaller sub problems to solve the main problems. So that is called actually substructure property, optimal substructure property. That means we will start solving the sub problems and in that way we will get the final optimal solution for the main problem. So if any problems which can be solved by solving the sub problems, so that means that can be solved by the dynamic programming approach. Another things, optimal overlapping sub problems. So that means if we are solving some problems, some problems, and that is required to solve again and again during the complete process. So I'll take one example to explain this. So suppose this Fibonacci series. We are calculating the example of nth number in Fibonacci series. So this is given as a simple recursive approach. So this approach, this is the very easy question, easy problems. Here So here what we are doing, we are just using the recursive function and passing this n input. If this is less than or equal to 1, we are just returning n. Otherwise, we are just calculating the sum of what is the n minus 1 Fibonacci element and what is plus the n minus 2 of the Fibonacci sequence. So what is the n minus 1 term and what is the n minus 2 terms? So if we add this, so we will get the nth term. So in this case, if you see the recursive call structure for this, so you will find out that the same problem is required to solve again and again. So like here you can see in the recursive call, when we are calling this Fibonacci recursive function on 5. So this call is happening like this. For first, it will just move to this side, and after that, second side, then it will back to the another side. In this manner, the call will run. Okay. So in this sequence, you can see we are getting FIB2. That means we are solving this problem with 2 input n equal to 2, and the another side we are also again solving the same problem again. Okay, FIB2, the same input 2. So in this manner, you will find out that FIB1, FIB0, that call is happening multiple times in this process. So that means we are solving the same problems again and again during the process. So this is called as a overlapping subproblems. So if any problems contains this type of properties, that can be solved using this DP approach, dynamic programming approach. And instead of solving the problems every time, what we can do, we can use the memoization approach. So next thing is the memoization. If we solve any part once, so we will store the result for that part. Okay, suppose if we have get the solution for this FIB1, then if at any time if this occurs again in the process, so no need to further solve that that part. Just check what is the solution for this FIB1, which we have already solved before. So we will just check the solution directly, and we will use that solution without doing further recursive call. So here, suppose if this FIB2, this FIB2 we have solved first. Okay, so next time when we are just calling the again this FIB2, so there is no need to call recursively of FIB1, FIB2 0. We can directly return the answer from this call, because we have already solved this part before. So we will store the solution of this subproblems at some place, and we will use that solution later in the process if we are again trying to solve that part. Okay, similar you can see FIB3. So this part is again called here, and we have already done this side FIB3. Okay, so no need to further call the lower part. Okay, so no need to call this FIB2, FIB1, or F0 this part. We can directly return the solution from this point. So in this manner, how we can store this solution. So this is the techniques of memoization. We will just store the solution of subproblems in our memory table, and or dictionary or any list like this we can store, and at the repetition time we will just directly use the solution from our memory. So here you can see in the code. So what we are doing, we are just this is the base case of this recursive call. Yeah, this function. But after that we are checking if n not in mo. Okay, so this memo is actually a dictionary where we are storing the solution of the sub problems, and we are also checking this if n not in this memory. That means this n value we have not solved that solution for this n value. Then we will call this part. Okay, you will get the solution for FIB n-1 and plus FIB n-2, and we will store this solution into our memory MEMON. Okay, we are storing this solution in our memory. So in this manner we will solve this problem. So we will not continuously call all the recursive part, and we will check first if it is already solved in the previously. So we will directly use. Okay, so here return, you can see if this condition is not true, we are directly returning the answer from this part. So graph will look, this call structure will look like this. With the memoization techniques, we are calling the main from this FIB5. After that, this recursive call is going to this side, And here we have solved this FIB1 part, and we store the result for this is 1. Okay, so this is 1. Okay, and this is 0, so 0 we have solved. After that, that means 0 plus 1, we have solved this part FIB2 1, and we stored this result into our memory. And at that time when we are calling the same part again at some place, so here you can see FIB2, so no need to further call, then we can directly check this library, and we will check what is the solution for FIB2 in this memory. So this is 1, and we will directly return the 1 answer from this file. Okay, so that will actually reduce our recursive calls, and it will make our approach efficient. So this is called as a dynamic programming approach, and this memoization technique actually where we are starting from the top. Okay, and that approach is called as a top-down dynamic programming approach. Okay, we are starting from the main problems, and we are going into top-down manner, and we are solving from the down to up side. Okay, but we are starting from the top main call. So this is called as a top-down dynamic programming approach, and we also use the term memoization, and this is also a dynamic programming part. Okay, another is this is also a dynamic programming, but this is actually a bottom-up approach. Bottom-up approach means we will solve sub problem first, and we will get the overall solution to the main problems. So here, how you can think that we are just calling this function, and inside this function, this loop we are actually maintain here. Initially, all values are 0 in the table, and t0 is equal to 0 and t1 equal to 1, because we know that first term, 0th term is 0, and first term is the 1 in the Fibonacci series. After that, we will just use 2 previous values, and we will get the next value. Okay, so that we are doing by this loop. So here actually we just started with FIB. What is the solution for FIB 0, and what is the solution for FIB 1? So these are the sub problems. Okay, and this is the bottom up approach. That means we started from sub problems, and after that, after combining this, we got the solution for FIB 1, FIB 2. Okay, and after that, for next call, we will just add these two and get the FIB3. And in this manner, we are just using the solution of sub problems, and we are getting the solution of the main problems. So this graph is this call is like this. So this these are the base cases. We have the direct solution for this. This is 1, this is 0. After that, we are just simply using the solution of the previous problem, previous sub problems, to get the solution for the further problems. So for FIB2, we are getting the solution for this part and this part, these two sub problems, and we are using here, and we are getting the solution for this FIB2. And for next three FIB3, we are using the solution for FIB1 and FIB2, and we are getting the solution. So in this manner, we are starting from the sub problems, okay, lower problems, and we are getting the solution of the main problems. So that is called as a bottom-up approach. Okay, and this is also a dynamic programming approach, and this is efficient because we are also not using the recursive call in this. So that is recursive things is also costly things compared to the iterative things. Okay, so using the memory and using the tabulation form in this manner, we can also reduce this recursive things from the DP, and we can solve the problems using the normal iteration method also. Okay, so that is called as a bottom-up approach. So any approach you can use to solve this using dynamic programming. So these Fibonacci series, you can see we can solve that problems using the recursive approach, memoization approach, and the tabular form approach. And also some problems, so like you have already seen in the previous week, so coins problems. So I am not sure that is discussed, but that coins problem, some problems looks like greedy, that can be solved using the greedy approach, but you cannot solve. So like you have given some value of the coins, and with the infinite number of coins, so like 1, 5, and 7, 8, 10. So these are the coin values, and you have infinite number of these coins, and you need to find out the minimum number of coin to achieve some amount. So some amount is given, like what is the value. One second. So suppose this I am taking 2. Okay, suppose our amount is given like 15. So how we can achieve this amount by this number of coins? We can take any number of coins. If we apply the greedy approach for this, so we will always select the higher amount coins first, okay, and we will try to use the maximum number of coins for that higher amount coin. Okay, so suppose here if we takes 10 value coin, so we can take only one. Okay, so 1 into 10. Now amount is become 10. So now how many remaining amount is 5. So after that we have the coin 8 value. We cannot use because this if we use this, so our amount will become more than this. Then same 7 we cannot use, but then 2 we can use. Okay, so how many 2 coins we can use? So we can use 2 into 4. Sorry, this is 2 into 2.
2 coins. Yes, sir.
Okay, 4. Then we cannot use more. After that we can use 1 into 1. Total 15. So how many coins we need? 4. Okay, but we can also solve this by only 2 coins. 7 plus 8.
Yes.
Okay, 15. So this problem can be solved using with 2 coins. So like this actually. So that means here we need to check all the combination of the coins, not only from the like greedy approach. We cannot apply here. We cannot pick from the larger amount coin first like this. Here we need to check all the combinations. So our solution maybe we can get from any combination from the given given inputs. In that case, if you need to calculate all the possible combination. At that time, you can just use this dynamic programming approach to solve smartly. Okay, so then you can apply the DP approach. You can just find out that you can solve with the smaller problems, and you can get the final solution smartly without doing too much effort. So some examples are discussed in this week 9. So like this first problem is discussed this grid path. Okay, so grid path here some input point is given, this 0 0 point is given, and this is the destination point is given, and all these grid lines is actually representing the path. Okay, where you can move. So from this 0 0 point, any path you can choose, but you can only in one step you can only move to the right, or you can only move to the up, not left or not down. So this is the constraint for this problem. So in this case, that means you can move only either this direction and up direction. These 2 directions you can move. So how many paths are possible for this? So for this problem, how you can solve this using the DP approach? Because naive approach, definitely you will figure out here there are lots of possibility of the path. Okay, and then if you apply any naive approach, so that will become very difficult. So here you can figure out that if suppose you have a smaller problem with the same inputs like this, if you have smaller problems, so like suppose if you have only this 2, or we can start with this only this line, this line. So this point, first point, you can only move to this direction, and for each point, okay, so this is the first point, this is the second point, and for each point you have only single line. So that means only single path is possible for each point on this line. Okay, because you can only move this direction and you have only this grid line. So there's only single path for each point. So you can assume that from this point, starting point 0 0, only one path is possible for the first point. So we can assume this is 0, this is 1, this is 2, this is 3, this is 4, this is 5. Okay, and similarly we can also mention this coordinates with the column rows. Okay, so 0 1 2 3 4 5 6 7 8 9 and 10. Okay, so 10 rows and total 5 columns, total 6 columns starting from 0. So if you select only first grid, this 0 first grid, only one path is possible. So for the each point, so that means one path is possible for 0 to 2, 1 is possible for 0 to 3, 1 is possible for 0 to 4, 1 is possible for 0 to 5. Okay, similar on the upside. So if you suppose if you have only this grid path, grid line, only single line, so only one path is possible for each point. Okay, till the end. After, so this is the base case you can make. So this is the sub problems we are starting from here. After that, you can find out the solution for the sub problem. So like suppose if you are calculating the solution for this point 1 1, okay, column 1 and row 1. So how many paths are possible for this point? So you can come either from this side and you can come either from this side. Okay, so 2 paths are possible. So that means you can take this value as one input and this value as a second input. So 1 plus 1, you can just get the solution here 2. Okay, so that means 2 paths are possible from 0 0 to 1 1 point. Now you get the you have solved this problems. Okay, this is the one sub problems. Now we are trying to find out the next point, which is 1 2. Okay, if I'm taking, okay, second point we are taking as a rows. So 2 1. Okay, 2 is the column and row is the 1. 2 1. So at this point, so for the previous point 1 1, you have 2 paths. After that, you can only come through this path. Okay, so that means you can take this 2 value. You can come at this point by 2 different paths. So just use this 2 plus and another possibility from the lower side. So that is only one path. Okay, so from this side, lower side. Okay, so you can take this direct value 1 here and 2 plus 1, you will get 3. So 3 different unique paths are possible from 0 0 to this 2 1 point. In this manner, you can get the solution. So that means just check the previous adjacent left value. What is the solution for the left part and what is the solution for the bottom part? Okay, and add those solution to get the solution at that point. So we can make this as an induction for these problems, and we can get the solution for this 5 comma 10, this point. Okay, so in this manner you will get 3 plus 1. Okay, so 3 plus 1 4, solution for this point. Next point 4 plus 1 5, and next point 5 plus this is also 1, so 6. Okay, now you get the solution for this line and you can start from the next rows. So 1 plus 2 3, it will become 3, and 3 plus 3 will become 6, and 6 plus 4 10. Like this, then you can solve in this manner and you will get the final answer for this point. Okay, so here we are starting from the lower problems and we are getting the solution for the main problem. So 0 0 to 5 10 points. So we can make these condition as an induction for this. So you can get you can check. So we are using only this formula for this. Before that, we have to initialize the base case. So base case is initialized like this. So p 0 0 equal to 1 base case, and if I equal to any value and j is 0, so we will just check that. Okay, so all value are assigned by the, okay, this is mentioned here. Yeah, so in this diagram you can easily understand. So all value are actually assigned by the 1, this said 1. After that, we are applying that formula. We are taking the left value and bottom value and adding that. So this is the simple problems. We are calculating the total number of paths, but the different problems may be also arise here with the same line. So here some blockage point is given in this problem. So you can see these are the blockage point where we cannot use this point to move. So that means how many paths are possible? Then 0 0 to 5 10. Okay. So at this problem, we will similarly we will solve from the base case at this point, because there's no movement possible from this point. So we will consider that 0 path is possible at this point. Okay, so we will take 0 value from here, and so this 0 will be add further. So here 6 and 0 will get 6. So you can get the solution for 6 here. Similarly here, so this 0 value is taken for this blockage point. So 26 plus 0, 26 we are getting. After that, we are solving in the similar manner, and we will get the final answer this at this point. Okay, so this problems will be arise with some blockage also in the path, and we can applying this dynamic programming approach to solve this from the bottom up approach. So here some comparison is also mentioned. So this code is also given in the notes. So you can just look this code. So this recursive solution is also mentioned. Okay, how we can solve this using recursively, and using the memoization techniques, how we can solve, and simple this tabulation form. Okay, bottom up approach. So all three techniques are given. Just go through these codes first. Try to solve by your own. If after that you can just see this code also. And another comparison is also given here, this memoization versus dynamic programming. Okay, so memoization means we will use this top-down approach, and this dynamic programming we will use this bottom-up approach. So what is the disadvantage if we are using memoization? So in memoization case, points are given. Barrier of host just inside the okay, memoization never explore the shaded region. Okay, yeah. So here this problem is given. Suppose if you have input is given like this. So this yellow region, actually this is the okay region, but these are the blockage. Okay, so all these square black shaded is actually blockage, and these are the final destination point, and this is the initial point. Okay, so if you apply the dynamic programming approach, so that means you will start from the same thing. So okay, so this is one like this, and you will solve this problem from bottom up manner, and you will get the solution till this point. Okay, and after that you find out that there is a blockage. So all will get you will get 0 at this point. Okay, so that means there is no benefits you are getting from this yellow region part. You have already solved this part by this dynamic programming approach, but after that you are getting blockage, and you will there is no use for this yellow region solution. Okay, at the same point, if you apply the memoization technique on this, so that means you will start from this point, and using this recursive things, you will just check what is the solution for this side and what is the solution for this side. Okay, and you will get solution here. So so this is the first call. After that, from this point recursively call, you will get check what is the solution for this side and what is the solution for this side. Okay, so here you will get the blockage, and you will get directly 0 answer from this side. Okay, so you will not enter this yellow region by this. Okay, so similarly here you will check for this left side and bottom side. Once again you will stop at this point. You will get the direct solution here for the blockage. So in this manner, at this point you will reach. So here only one solution is possible. Same here, one is solution possible. So you will only look this part. So this and like, okay. So in this manner you will reach at this point, but you never enter on in this part, yellow region. Okay, so here you will get the solution after looking only these calls by this blockage. So that effort actually of this yellow region is not happening in the memoization process, and in this situation actually memoization technique is better. So this is advantage is given if this type of situation is there. So dynamic programming is actually taking more time compared to the memoization techniques, but most of the time actually dynamic programming is still better in the normal problems. Okay, so this type of situation is actually occurs rarely. So here complexity, you can also mention that complexity is m into n using dynamic programming, but m plus n using memoization. So m into n because we are calculating the each crossing point, so we are performing all into m into n cells. But memoization techniques, we are just going this side and only this side. So this is number of rows and number of columns. So we are getting m plus n. For this type of situation, actually memoization is better. But in general, DP approach, this bottom-up approach is actually better. So this is grid path problem. So you can try to code for this. So you can see this recursive solution. You can see we are assuming that if x is less than equal to 1 and y is less than equal to 1, we are directly written 1. Otherwise, if any barrier is there, so we are passing this coordinates. So x and y, this is the final coordinate, and barrier. What are the barrier points? So barrier, if barrier is mentioned in the diagram, so you can just consider that barrier point and assume that 0 value you will get from this point. So otherwise we are calling recursively on the left part and bottom part. Okay, this is simply a recursive call, so this will perform completely. But using memoization table, we can store the result in our memo table, and we will check the solution in memo table first. If it is not available, then we will calculate the solution and we will store that solution in our memo table. Okay, so this is memoization technique, and this is tabulation form where we will start from the lower point. Okay, so you can see first we will initialize all the row and column point at 1. Okay, so and remaining are 0 matrix. Okay, we are maintaining one 2-dimensional matrix for each point. So we are initializing these points, and in the another loop we are solving this. First we are looking the solution in, okay, so this is barrier point, so we are assigning the barrier point. Otherwise we are getting the solution. You can see from left, this is the left point and this is the bottom point, I-1, and this is J-1. We are directly getting the solution. Okay, so you can solve these problems by the both all approach. So suppose if any problems comes in the OPP regarding this dynamic programming approach, so you can also try that problems, because if there's no efficiency is checking in the problems, there is no complexity is given in the problem, you can also apply the recursive approach. Okay, so there's no restriction on this. You can apply simple that memoization techniques, you can apply recursive approach, you can also apply this tabulation bottom up approach. Okay, any approach you can apply to get the solution. So next problem is discuss this longest common subword. So subword is basically substrings, we can also say. That means continuous. We will check the longest common substrings or subword. That means the characters should become continuously in both strings. There. Okay, so what are the common subword is there in 2 strings? Okay, and similar type of problems we have common longest common subsequence, where we can skip some characters in the order. So that we will discuss after this. So this is common subword or substrings. So actually these are the main formula that we can find out by looking the sub problems first. Okay, how we can just assign the sub problems and how we can solve the sub problems and how we can use the solution of sub problems to solve the further problem. So here this table actually we are maintaining, so we can manage any matrix table, and corresponding index we are using these 2 strings. So this is the first string and this is the second strings. These are the 2 input strings we are taking, and we are finding out the longest length of the longest common substrings in this. Okay, so before solving this part, we are also assuming that, so you can see we are assigning one more size. So length of the bisect is 5, but we are taking the size of this matrix 6 rows and 6 columns. But our both strings have, so here this, okay, so this secret is actually by, okay, this is actually 6. Okay, 0 to 5 is 6 and then 7. So length of bisect is 6, but we are taking one more rows, and similarly we are taking one more columns in the another strings. So that is actually this dot, and this dot is just representing a empty strings. Empty strings. If S1 and S2 is given, suppose if S1 is given, S2 is given, okay, and there's no characters in this, this is totally empty, both are empty, then what is the solution? What is the possible solution for that? So if there's no characters are there, though both are empty, definitely 0 length is there, which are common. Okay, so we are filling this matrix by 0. Okay, you can see, and this is the point actually where dot dot is there, so that means both strings are empty. And if one is empty and another have some characters, so like S1 have A, okay, but S2 have only empty, then still you will get 0 length. Okay, and if this B, this contains more character but S2 is empty, but still you will get the 0 length in the solution. So that is actually representing here. For this 6 point, we are assuming that if both are empty, this dot point, we are getting this 0 solution. If that this, suppose this is S1 and this is S2, this side, Okay, if S1 have some character like T, but we are assuming that our S2 doesn't have, S2 is empty, this dot. Okay, because of that we are getting zero solution again. Okay, if S2 have two character ET, but S1 have two character ET, but S2 have empty, you will get zero length. Someone is raising hand. Yeah, Karthikeyan.
Actually, this last question I'm not able to understand. Even the problem statement, what
Which
we are trying to do here. The previous one is okay. This longest common subword, even problem statement, I'm not able to understand.
Okay, so here two strings are given, S1 and S2. Okay, that contains any strings. So like here this two example is given, so S E C R E T. Okay, and another is bisect, so B I S E C T. Two strings are there. So longest common subword means you need to find out the common substrings from these strings, and that substring should be continuous. So what is the longest length possible for the substrings which is actually common in this S1 and S2? Okay, so here you can find out that SEC, this SEC, and here is also coming this SEC. Okay, so the length of this SEC equal to 3. So similar to this, if you have any substring which have more than this length, then that will be the answer. So we are looking this type of substrings in the given strings which are common and have the longest length. Okay, so this is the problem we are looking. We are getting the longest length. So how we are solving this? We are solving this using dynamic programming approach. So we are finding out the all possible solution. Okay, so here we are getting the, because our solution may be come from any point. So in this example, you can see we are picking first 3 word from the S1, but the same word is appearing from the third character. Okay, so that matching may be happen from any point. So that means we have to check all possible combination here. So here we are maintaining this 2-dimensional matrix for the solution, and we are solving this problem from the sub problems, and sub problem is starting from this null strings. Okay, so this last point dot and dot, this is representing that both S1 and S2 have. So this side S2 and this side S1. Okay, so S1 and S2, if suppose S1 and S2 both have empty strings, so that means length of the longest common subword is 0. So nothing is common. Okay, and similarly, if S1 have some character but S2 is empty, then still you will get the 0 answer, because nothing is common, because one string is empty, so you will get 0. So similarly, for all possible combination with the, when we are assuming that one string is empty and another have some characters, so we are getting this 0. Okay, so we can make this as a base case for the sub problems directly, because we know that if one string is empty, you will always get 0. Similarly, we can consider that S1 is empty, okay, and S2 have some characters. So similarly, you will get the 0 length. So in this row also we are assuming this all 0. So this is one sub problems we have solved. After that, we will check what is the solution for this point. Okay, how we are getting this point solution. So we are looking the character from this side. So what character we have at index 5, and what character we have at index 5 on the S1, S2. Okay, if both are similar, because here we are looking the sub strings. Okay, so that means our characters should become continuously for the matching, not by skipping. So what we can do, we can you apply this inductive structure. If both are same, we will just get the solution of previous solution. So this is the solution of the previous sub problem. Okay, we will take this solution of from this diagonal position, and we will add 1. So what is the solution for the previous diagonal position, and we will add 1 value into that because this point is representing the maximum possible solution. And if our next character is matching, so that we will add one more value on that. Okay, so here you can see we are getting 0 plus 1 solution. Okay, so now we will repeat this process. We can fill this matrix either by row wise or column wise. In any way we can fill, or we can also fill diagonally, because every time we will look only these three value, diagonal value. Yeah, in this case we are only reading the diagonal value. Otherwise we will fill 0. Okay, so here you can see after this t. So now we are assuming S1 have t and S2 have t. So what is the solution of this answer? Okay, so only one length is, we found that for this subproblem. So this is one, we are getting your answer. But after that, when we are getting the solution from this side, so we are assuming two characters in S2. So that means S2 is now CT. Okay, and this point S1 have only t. We have already calculated the solution for this point. Okay, but now next character is not matching. So for this point, C is not matching with this T. Okay, so we will directly fill the answer for this is 0. C is not equal. Okay, so if suppose we are assuming that this C, we have new character at this point, and corresponding we have only T, so both are not matched, so that means no common length, 0. So in this manner, we will fill this matrix either horizontally or vertically or diagonally in any manner. At one point you can see at this point. Okay, so here C and C both are matched, so we will add one value from this point, so +1, and we are getting 1. Okay, so now that this point and this points are matched, when we check for this diagonally at this point, you can see, so this C and C is already matched. We are looking for this E and D. Okay, so what we will do, if both characters are matched, then we will use the previous solution. What is the previous solution continuously? So we will look diagonally previously. So what are the maximum length we have? This continuous we have maximum, that is actually still 1. Only this is only 1. So that means previous solution we have found one character match, and continuously we are getting one more. So we are adding 1 plus 1, 2 at this point. Okay, similarly, if you are getting continuously one more character match, then we are just reading the solution from this point and adding 1, 3. After that, this is I and no correspond match. Okay, so then we are filling 0, 0 like. Okay, so in this manner we are looking all possible combinations, because this is a two-dimensional matrix, so we will just checking the all possible solution for between two matrix, but we are not calculating the one things again, and we are reusing the solution of the previous subproblems. Okay, so in this manner we will get the solution in n square complexity. So if suppose length of this both strings are n, so we are simply performing n square operation and we are getting the final solution. And what will be the answer? What answer will be the maximum among all the values in our matrix. So we are getting this value as a maximum. So this will represent a maximum length among which are common in both strings. So that will be the answer. So this is the main important point. So this formula you can remember for this type of problems, and you can write the code later. So this is the, you can see if characters are not matched, we will fill our matrix by I comma j by 0. If characters are matched, okay, so if this condition is true, then we will read the diagonal solution. So this LCW is representing a solution of this point I plus 1 and j plus 1, and we will read the solution of this subproblem and we will add 1, and we will fill this value at this point. In this manner we will complete this matrix, and later we will just return the maximum value among the matrix. So the same we are writing in the code. You can see first we are filling this same matrix all value by 0, and after that we are checking if the characters are matched, then we are reading the diagonal value and adding 1. Otherwise we are filling 0. So same inductive formula we are using here, and same times we are also finding out the maximum value. Otherwise, you can directly return the max of this list. So, and later we are just returning the maximum value in the whole matrix. So that will represent the maximum length. So this type of problems actually are returning the length of the common substrings. But suppose if we ask that what is the common strings, then multiple solutions are possible, because in any two strings there is a chance more than one substrings have the same maximum length which are common. So multiple solutions are possible, but you can get one answer for this. So you can figure out that where is the maximum value, okay, where is the maximum value in our matrix, and corresponding character you can start taking, and diagonally you can just read the value. So here you are getting 3 is the maximum, okay, but what is the corresponding character is s. After that, just move to the diagonal side till the 1 value, okay. So 3, then just read the what is the corresponding value is e. Just move to the diagonal lower side, and what is the corresponding value is c. So s e c, this solution you will get. But there is a chance in the same matrix that 3 value come at many points. So there are multiple solutions are possible for the same maximum length. So this type of question is actually generally asked: what is the maximum length, what is the minimum length, what is the, so this maximum and minimum and maximum count, like this type of information generally be written by this TP solutions, not the what is the substring value. So that at that point multiple solutions are possible. So this is LCW, longest common subword. And on the same line we have the another problem, longest common subsequence. So subsequence means if you have two strings, so order should not be changed, and when we are picking the common characters, order should not be changed, but we can skip some value in the between. Okay, so here see the strings are same both. Okay, so S E R E T and by. Okay, so S1, suppose this is S1 and this is S2. Here we can pick the character like this S E C. Okay, these are the continually matched. Okay, this is fine. But after that, we can skip some character in one strings like this R E. We can skip, then T we are finding match. Okay, so what is the length of this subsequence? So this is called as a subsequence, where there is no need to check the characters continuously, but we will maintain the order. Okay, we cannot match like this, so we cannot match any character which are coming after this SEC later in the first string, but if suppose this is coming at the first, so we cannot change the order with the matchings. Okay, so same order we will take from this left to side, and same order we have to maintain on this side for the matching, and we can skip the characters in between. So what is the longest length which are common of the subsequence? So this is different problem, and here only small inductive structure change is required. So same things, we will start with the base case. So base case is the same. If both strings are empty, if any strings is empty, okay, so both strings are empty, only this point will fill. Okay, but if any one string is empty, so this complete row will fill by 0, and similar this list will fill by 0. Okay, so this is now become a base subproblem. After that, we can fill in the same manner. We can either fill row wise, column wise, or diagonally. And at this point, we will also keep maintain the previous subsequence match length. In the previous solution, because we are looking for the continuous match, so if our characters are not matched, then we were filled by the 0. But here we will just keep maintain the previous maximum solution. What are the maximum subsequence length we have achieved in the previous subproblems? So at any point, if our characters are matched, then we will add the value diagonally in the similar manner. Okay, 0 plus 1 like this. If characters are not matched, then we will check the maximum value of our right and bottom. what is the maximum solution we have till at that point. So we will keep maintain that solution to find out the next our subsequence lines. So here you can see if t and t both are meshed, so we are just adding diagonally at this point 1, 0 plus 1. If next point, suppose if this c and t, okay, here we are just assuming this c character only and this side is t. So these are both are not meshed, so we are just assuming that this solution. So this is the maximum solution we have. So here this ct and c, but c are not meshed, so we are just assuming that till now we have one character is already meshed tt. Okay, so this one we are maintaining maximum among right and bottom value. So we are picking the maximum. Same, E and T are not meshed, so we are picking the maximum this from this side. Similarly, for this point, we are maintaining this. Okay. At next level, if we are looking this value, so you can see T and E both are not meshed. So what is the maximum value among right and bottom? 1. So we are maintaining 1. And similarly here. But after that, at this point, you can see when we are calculating C, and C is also here. So we are adding one value at this point. Okay, 1 plus 1, 2. So in the similar way, we will add if our characters are matched, but we are not replacing by 0 if our characters are not matched. We are also maintaining the previous maximum solution. So in this manner, we will get the final answer at this point top. Okay. So at this 0, 0 point in our resultant matrix, we will get our maximum value. Okay. So the inductive structure is also, we can define the same manner. If characters are not matched, then we are looking the maximum solution among the right and bottom solution. Okay. Otherwise, so this LCS should also be capital. Okay. So LCS. If characters are matched, read the diagonal value and add 1. Okay, so you will get the longest common subsequence length here, and later return the value of what value you are getting at 0, 0 point. That is the solution. So code is very similar to the previous one. We are just maintaining as like the similar. First we are filling all 0. After that we are filling all point by this inductive structure. Okay, if characters are matched, then diagonal plus 1. Otherwise, maximum among bottom or right, both. And later we are returning the answer LCS 0, 0. Same things, multiple possible solution are possible for this also. Multiple subsequence are possible with the same maximum length. So this type of problem generally asks for the value of the length, not the subsequence. Okay. But you can also get the return the solution. So here, this is the point where you are getting the maximum value. So you can move where you are getting the similar value. Okay, if you can just check what is the right value and what is the bottom value. If you have any similar value, you can move that side. If both are different value, then move diagonal side. And when you're moving diagonal side, just keep the character, what is the corresponding character. Okay, so here 4, 4, you are moving this side, then 4 again, this is the same, you move this side, but from here right side is lower, left small, this lower one, lower is also smaller. Okay, so both are now different value. So at this point we will move diagonally and we will maintain this S. Okay, and this side again we will check. So this side 2, this side 2, both are different. Again we will move diagonally, so we will check what is the character of corresponding this E. And same, this side 1, this side 1, move diagonally. So what is the value for this is C. And again the for this point, okay, so this point, okay, for this point actually you have the same value on the right, so moves right side, then at this point you are getting both smaller value, so read the corresponding value T. So this SECT is the one possible solution we are getting for this. So this is the part which is actually subsequence with the maximum length, which is common into both strings. So you can get the exact solution also, but multiple solutions are possible. So in general, the length is actually asked for this type of problems. Next is added distance. So added distance problem is basically very useful algorithms in the checking of the plagiarism type. Okay, when we want to compare two documents of the strings. So what is the similarity ratio? What is the similarity percentage is there in the two document? So if you know the plagiarism things, so if you are comparing two documents and what percentage are the similarity in the two documents, so that we can figure out this figure out by this added distance algorithms. So what are the minimum distance? What is the minimum difference is there between two strings? Okay, so basically, if we have two strings and we want to make, suppose we have S1 and S2. S1 is something, S2 is something, and we want to make S1 is similar to the S2. So what are the minimum operation is required in S1? So it become equivalent to the S2. Okay, and for operation you can perform some operation like you can delete the character. Okay, and you can insert new character and you can update the character. Delete the character, insert a new character, and update the character. That means if some character is U and another in another strings another T, so you can update this by T. This is update operation. Okay, so you can perform these three operations. So what are the minimum number of operations is required to make one string equivalent to the another strings? So that is actually called as the added distance. So here to one example is given. So this SECRET. So this is given like SECRET, and this is the bisect. Okay, so this is S1, S2. So how we can make S1 equal to the S2? So what is the minimum number of operations is required on S1? So it become equivalent to the S2. Same things, same operation we can do from the S2 side. So we can perform some operation on the S2 and it should become equivalent to the S1. So what are the minimum number of operations required? So that is called as a edit. So we are performing some edit operation. And what are the minimum edit possible? Okay, so this is also represent the minimum or minimum difference in two strings. Okay, so in general, if you look these two strings, so how we can make the change? So here SEC and T we have, and this is SET, SECT. It's also there. So what we can do, we can remove these two characters. Okay, from this side we can delete this and we can add two characters here, PI. Okay, so two delete operation is performing and two insert operation is performing. So now after performing these four operations, we are getting the similar S1 and S2, BISECT. Okay, and similarly we can perform the things here. So what we can do, we can remove this. Okay, and SECRA, we can insert two characters here. Okay, so two delete operation from this BI and two insert operation in between C and T. So you will now S2 becoming S1. So total minimum 4 operation is required. So you cannot make similar compared to this 4 operation. You cannot make similar in the minimum compared to this. Okay. So how we can figure out this added distance? What are the minimum number of edit required in between two operations? So this time we are looking for the minimum. Previous time we are finding out the longest common substrings. Okay, so our inductive structure will also be changed in the same manner. So if you look this inductive structure, so what we will do, so basically we are looking for the minimum answer. So base case, how we can make the base case here? So if both strings are empty, then minimum edit distance is 0. No, both are same. Okay, so 0 edit distance, 0 difference. But if one string is empty, suppose this said S one this side S1, this is side S2. If S1 is empty and S2 have some character, suppose this have only T character, so you need at least one insert operation to make similar, okay? Because S2 is T, S1 is now empty. So you have to add one T character, so that will become equivalent. So one operation is required if the another length is 1, okay? Similarly, if another string's length is 2 and your S1 is empty, then you need 2 insert operation to make similar. So this is totally depends on the length of the another strings. If we have 3 character, 3 insert operation is required, okay? In this manner, we can fill this base case directly and similar to this side, okay? 1, 2, 3, 6. After that, we can use the inductive structure to solve the further problem. If our characters are same, okay? If our characters are same, then that means no edit operation is required, okay? Then we will pick the previous minimum solution. What is the previous minimum solution we have? So diagonal solution, okay? So if both are same, we are directly picking the diagonal value without adding anything, okay? Here, because we are looking the minimum edit. So if both are same, we are directly picking this side. If both are different, then we will check the all possible things on this point at this point. That means we will check the right side solution, bottom side solution, and bottom the diagonal side also. Which one is the minimum among all 3? And we will pick the minimum one. So this inductive structure, yeah, after picking the minimum one, because we need, if our current character is not matched, so that means we need one edit operation more. So first we will look the what is the minimum solution possible from the previous subproblems, and we will add one more operation, edit operation. So that will become a inductive structure for this. If characters are not same, then we will check the left, right, and then bottom and the diagonal, all 3 value, and find out the minimum, and then we will add one more, okay? So in this manner, we will just maintain the minimum edit distance in this matrix for all possible matching, okay? So we will fill this matrix in this manner, and we will overall we will find out the solution at this point 0, 0, and that will represent the minimum edit distance. So this algorithm is also similar. So here we are filling the base case first, then after that we are filling this matrix completely, and this is the inductive structure part. If both are same, then we are looking the diagonal value directly. Otherwise, we are looking the minimum, all 3 value, and +1, and returning the 0, 0 position value. So this is actually minimum edit distance algorithm. Okay, so you can remember, for the exam purpose, you can remember this inductive structure for each algorithm, okay? These LCS, LCW, and edit distance. So very small changes there. So just remember this, because if suppose it's the input strings are given, so maybe you can try randomly by looking the strings, but by that process you may get incorrect answer also. So just if a string's length is like 6 or 7, so just create a matrix of this type. So after just practice for some strings to fill this matrix by the inductive structure. This is very simple. You can directly fill this quickly by just looking the value. If both are same, just read the diagonal value and +1 like this. So after practicing on 1 or 2 problems, you will get this inductive structure clearly. So yeah, these 3. And last problem is discussed this matrix multiplication. Okay, so this is also matrix multiplication. If you know the matrix, when we multiply the two matrix, so we perform some multiplication operation in between the elements. So how we can minimize that multiplication operation, that is the problem. And we have some constraint also for that. So here some example is given. So first thing, matrix we can only multiply if our rows is actually, suppose we have two matrix M1 and M2. Okay, so M1 size is like 2 into 4, and matrix 2 size is like 4 into 3. Okay, then we can multiply. Okay, so this is row and this is column. So the column of the column value of the first matrix should be equivalent to the rows value of the second matrix. Then we can multiply this size matrix. So the number of operations required to perform the multiplication of two matrix M1 dot M2. Okay, so this order we cannot change because this is because of this. Okay, 2 into 4 and 4 into 3, like this. So we cannot change M2 into M1 because then this 3 is not equivalent to this 2. So if we multiply in this order, so the total number of operation is required 2 into 4 into 3. Okay, so this 2, then 1 for the common value, and 3. So 2, 4 into 8 and 24 multiplication is required. So we can calculate the number of multiplication by this formula. And so this is the one possibility. If you have M1 and M2, only this one possibility is there. Okay, you can perform the multiplication. But suppose if you have more than two matrix, okay, so like M1, M2, M3, then how you can multiply? So you can assume that the size is actually according to the constraint. So the number of columns of the M1 is actually equivalent to the M2 number of rows. So order we cannot change, but we can pick any two matrix first. Like how we can pick here. So first we can multiply this two pair. We can multiply pairwise only. So first, suppose if we multiply M2 into M3, then we will get a resultant matrix of this, and then we can multiply with the M1. So suppose this is the MR, or we can say that this is the M23. Okay, and then M1, then we can multiply that. Okay, so this is the one possible order. And we can also do in the different way, 1, M2, M3. We can first multiply this M1, M2, and then multiply the resultant of this is with the M3. So this is like M2 and then M3, like this. So order here you can see we are getting two different order for the multiplication. So among these two, which one is the optimal? So optimal, if we suppose if we take one example for this, so like we have M1 of size 1 into 2, M2 2 into 4, M3 4 into 1, like this. Okay, so we have three matrix. Suppose if we do M1, M2, M3, and we perform M2, M3 first. Okay, so that means we will multiply by 2 into 4 into 1. So this is the first operation. After that, we will get the resultant matrix of size 2 into 1. Okay, and we will multiply this matrix by this. So that means 1 into 2, 1 into 2 into 1 plus this 2 into 4 into 1. So this is the total number of operation to multiply. So this is 1 into 2, 2 to 1, 2 plus 8. Okay, total 10. If we are following this order, we are getting total number of multiplication 10. Suppose if we change the order, if we perform M1, M2 first and then M3. So M1, M2, 1 into 2 plus into 4. So 1 into 2 into 4. And you will get 1 into 4 matrix size. And that, so plus. So after that, 1 into 4, okay, into 1. So how many operations are there? You can see 8 plus 4, 12. So here this time this is 10, here this is 12. So you can see if we are changing the order of multiplication, then we are getting the different number of multiplication. So among all the possible order, which one is the optimal? That means which order contains the minimum number of multiplication. So that actually we are trying to figure out this. So in this process, actually we are finding out that what are the minimum number of multiplication required. So here in input, we are giving two matrices, not two, more than two matrices. And so like this, one second. So you can see this example. So here some metrics are given: M0, M1, M2, M3, M4. So total 5 metrics are given. Okay, and indexing is also mentioned, and the dimension is also mentioned. So each matrix dimension is there. So what are the minimum number of operations required? Because we can here find out different order. Okay, we can perform M0, M1 first, then with 2. There are multiple possibility are there for the selection of pair, but which order is actually optimal, and what is the number of operation for that? So that actually we are calculating by this algorithm, matrix multiplication algorithm. And for to fill this, actually we are looking only for the diagonal side. So this thing is actually representing the matrix, how many matrix we have. Suppose we have 5 matrix, so that means 0, 1, 2, 3, 4, 5. Only 5 columns are required. So in this C, you can see this is representing 0 matrix, M0, 1, 2, 3, 4, and 0, 1, 2, 3, 4. Okay, so this is representing the number of matrix we have. So we have total M0 to M4 matrix. And we are looking for the all possible ordering solution, but we will just solve this by the smartly and without repeating the process. So but here we can ignore the diagonal solution also, because this side also we are getting the same. Oh, we can also not pick, we cannot change the order here actually. So if we are looking the solution for this side, so this is representing, that means for this solution actually 0, 0. Okay, so we have only one matrix at this point. We have only one matrix M0. So is there any solution possible for this? No solution. Okay, so there is no solution. And if suppose if we have two matrix M0, M1, so once again we are performing the same things. So we are assuming this diagonal things as a base case. If suppose we have only one matrix, either M0, M1, then only 0 number of operation is required, because we cannot multiply the only single matrix. We need at least 2 matrix for the multiplication. After that, if we have 2 matrix, then we can only choose one order, M0, M1. So, okay, so what are the number of operations required if we have 2 matrix 0 and 1? So only one order is required. If we have 3 matrix M0, M1, M2, okay, then what are the option required? So in this case we have multiple options. So you can see for this situation we are getting 2 answers. So this is representing, suppose if we pick 0, so that means if we pick this value first and we'll multiply with the different one. So this is the 0 is the point. This is the breaking point actually. We are multiplying this part first and then this one. So we are getting one possible solution. If we are breaking this like from the 1 point, M1, M2. Okay, so this is representing the 1 point. So that means if we perform this solution first and then multiply with M2, then what is the solution? Okay, so in this manner we are solving this also from the sub problem manner, and we are getting the solution for each possibility. Okay, and finally at this point, so this point is representing the when we have all number of matrix, so 0 to 4. So this point is actually representing the minimum number of multiplication possible. So here if you see the algorithm, so this inductive structure we are following to fill, and we will fill this diagonally because 1, 2. This part is not required because we are making this diagonal as a base case, and after that we are looking when we are calculating this value. So we will use the previous solution from lower side and that left side, and we will directly put this. So if you see the solution, so here you can see if I and j are same, then we are filling that 0. So this is for the diagonal value, and we are assuming that we have only one matrix. Otherwise, if I is less than j, so you can see this condition is actually we are taking we want to fill only the upper diagonal, not the lower diagonal. If this is true, then we will pick this min value of, and here the dividation point is different. Okay, so if we are taking m0, m1, m2, m3, so this k is actually representing the dividing point. So if we are taking is equivalent to I, so we can break this point first, and what is the solution for this part? Okay, we will check. We have already solved this part, then we will check the solution for this part and directly, and we will calculate the solution multiplication with this m0. So we will break the problem into sub problems, and we will check that sub problem is already solved. Then we will directly pick the solution from the table and directly put here. So that we are doing. Actually, you can see the Cik. Okay, we are filling the solution of Cij point, but Cik and Ck plus 1j, this value we are directly picking from our previous solution. And after getting this point, we are also adding the new number of multiplication. Okay, but here multiple possibility are there for the dividing process. So we are taking this k loop. So that means this value we will check for the each k value, and after that we will find out the minimum. Okay, so as I mentioned that if we have let's just explain for one example how we are getting this. So this is simple. So here we have only two matrices, m0 and m1, and size is, you can see, 4, 10, and 3. This is the size. So we are getting directly this. So 4 into 10 into 3. This is 40 into 3, 120. So this is only simple, because if we have two matrices, only one pair is possible. But for this situation, okay, so we have filled. Okay, yeah, this matrix actually we fill diagonally. So first we fill this part, and second we will fill in this manner. So if we have checked this, then next we will check this, because for each solution we need sub problem from either this side or this side. So because of that we are filling diagonally. So here we will check this point. So if suppose we have m0, m1, m2, okay, and size for this is 4, 10, 10, 3, and 3, 12. Okay, this. So how we can find out the minimum solution for this? So we will, so this point is representing the 0 and 2. So that means what is the solution for this at 0 to 2? Okay, so now breaking point, if you see the inductive structure, so this I and 0 and this 2, and k value we can take from 0, but should be less than to j. That means k value can be either 0 and 1. Okay, because j value is not 2, so we can take either 0 and 1. So this 0 and 1 simply is representing the division process. If we are taking 0, so that means we are breaking this point, and if we are taking 1, so that means we are breaking from this point. So we will fill this matrix here. So Cik, so Cik, so Ik means I is 0 and k is, because if you are taking k equal to 0, so it will remain 0. Okay, plus Ck plus 1. So 0 plus 1 will become 1, and j is now 2. Okay, so you can see C00 and C12. What are the point is there? So C00, we are filling this point. Okay, so C00 is representing the this value, this value, and C10 is representing the 0, 1, 0, 2, 0, 1, 2, 3, 4. Okay, so this value, this point is representing not 0. Okay, okay. This point is actually 1 and 2. Incorrectly. 1 and okay. So for diagonal case, if we are taking 1, 2, and there is no possible different solution possible, that means we are considering M1 and M2 only, two matrix. So for this point, actually M1 and M2, we are considering only M1 and M2, and only one solution is possible. So M1, M2 means we are multiplying this 10 into 3 into 12, then direct 360. Okay, and for this point, you can see. So 2 and 3. So we are considering the matrix only M2 and M3 as input. So only one pair is possible for this combination. So that means 3 into 12 into 20. So we are getting the answer of 720. And here M3 and M4. So this diagonal is representing only two matrices in the input. Next diagonal will consider as a three matrix in the input. So for this case, so for this value 264, so 0 and 2. Yeah, this is the case we have 0 and 2. So we have already calculated this. So for C00 and C12, so you can see for this position 0, 0 is representing this point and 1, 2 is representing this point. This inductive structure IK 0, 0, yeah. And remaining part, because we are considering this as input, and remaining is dimension I0. So dimension I0 is just a I is 0, 0 matrix. Okay, I0. So what is the value for the first dimension? So this is 4. So this is actually 4 into k is now 0, so 0, 1. This is the second value we are getting 10 into j. So j is representing 2 and 1. That means last matrix this. Okay, so we are simply applying this inductive structure for each value of k, and then we will check what value we are getting. So this 0, 0 we are getting 0 plus C1, 2 we are getting 2, some here to 360. So 360 and plus this calculation. Okay, so first we will calculate this point for when k equal to 0. Similarly, we will calculate k for 1. So that is the another possibility, and we will check the another value. And finding, we will select the minimum one. So basically, we are finding out the all possible orders. So M0, M1, M2. So first we are looking the dividation for this point, and we are directly picking the solution for this M1, M2 because we have already done this before M1, M2. Okay, and checking how many possible multiplications are there. Then we are dividing from M0, M1, M2 at this point. And this part we have already done before, and we are directly reading the solution for this part, and after getting the multiplication for the next part, and what is the number of operations. And out of these two number of operations, so suppose this is K1, sorry, this is R1 and this is R2, what is the minimum value among these? And that we are picking at the matrix, so at this point. So same way we are reusing the solution of the sub problems directly, and we are getting the solution for the problem. In this manner, we will fill this matrix, and we will get the minimum number of multiplication at this point in this matrix. Okay, so this is representing that this number of minimum multiplication. So this is matrix multiplication algorithm. So this part actually I have also expand more. This is not discussed in the lecture, but we can also find out the what order we should take to get this minimum number of multiplication. So if we keep maintain the k value, if when we are applying this inductive structure, and every time we are taking this k value, and so for what k value we are getting the minimum value actually. Okay, So we can keep maintain that k value to get the minimum value at each point. So you can see for k equal to 0, we are getting this 120. For k equal to 1, we are getting this 360. So we are just maintaining this k value with the each value, and then we can find out the order also. So here you can see this. Initially, we have total 5 matrix M0 to M4. Then we can find out the first break based on this k value. So at this point, we have 0 to 4, 0 to 4. We have this k value 1 for the minimum solution. So that means first break we can apply from the this 1 point. So M0, M1, M2, M3, M4. So first break we can apply at this 1 point. So now we have 2 part. So this part we cannot further break because these have 2, but this part we can again decide. So first index is 2 and last index is 4. So 2 and 4. So just check 2 and 4. So 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. So 2 and 4. So what is the k value is here? So this is 3. So that means another break we have to put here. So M2, M3. So that means we need to multiply in this order. So 0, M1. This will be the first. And in the remaining part, M2, M3, and M4. So this should be the multiplication order to get the minimum number of multiplications operations. So if we keep maintain the k value, so then we can also figure out the what should be the order of multiplication. So that you can check in the notes, and you can solve one problem, and you will get this inductive structure, how it is working. So this is the last topic. Any query, anyone?
Possible extension for the week 9?
No, there's no extension. Actually, I tried today. I asked to the ops team, but they said they need to finalize the eligibility criteria for end terms. They cannot extend. Yeah.
Okay.
Okay. So, any query in this, or any query then?
So, can you please check why my answer transcript is not opening?
That I'll just convey to them. So, just try again tomorrow. Okay.
Okay. Should I write to the support team also?
You can try. You can also write, but I'll also convey.
Okay. Thank you, sir.
Okay. Then this week we will discuss
Thank you,
the
sir.
DB problems. Yeah. Okay. Thanks. So, in the lab coding problems. Okay. Yeah. Okay. So if nothing, there's no query, then we can close this.
The OPP preparation sessions, when are they likely to start?
From this Monday.
Coming Monday. That will give us just about a week's time then.
Yeah. But week 9 is also important for the OPP. Okay. So just also join this live coding session on Friday.
Sure. Just wanted to. Yeah. Thank you.
Okay. Yeah. Thanks, everyone.
Thank you. Thank you. Right.
Thank you.